In this question, we have a word problem that states, Jimmy invests $16,000 in an account that pays 8.22% compounded quarterly. How long in years and months will it take for his investment to reach $23,000? I'm going to highlight a portion of the problem that helps us. Right here, the question says that the interest is compounded quarterly, and that's an indication of which of the compounding formulas we're going to use. For compounding quarterly, we would use the formula A equals P times 1 plus R over N to the NT. And the reason why I know to use this formula is because compounded quarterly will tell us the value of N to be 4. N is the number of times interest is compounded in 1 year. We have some other pieces of information in the problem. Jimmy invests $16,000, and that is P, our principal, or our initial investment. The account has an interest rate of 8.22%, and that is R, the annual interest rate. Right here, the way the question is phrased, it says how long, and that refers to time, and that is our unknown in this question that we'll want to solve for. And how long will it take for our investment to reach $23,000? That is A, our accrued amount or our ending amount, the amount that the investment grows to over that period of time. So looking at our formula, I have a value of A to substitute here, a value of P to substitute here, a value of N, a value of R, another value of N, and our unknown, which we're hoping to figure out. So I have all of the variables except for the one I'm looking for, and I'll be able to solve this equation for that variable. So I'll make those substitutions to get $23,000 equals $16,000 times 1 plus R. R is the interest rate. We want to make sure we write that R in decimal form rather than percentage form. So we're going to move that decimal point 2 places to the left, making this 0.0822. Because the interest is compounded quarterly, I have the value of N to be 4. And then in the exponent, N is 4 and T is the unknown. So now I have an equation. This is an exponential equation because the variable is in the exponent. And I'm going to solve this with some exponential techniques. So with those exponential techniques, I want to isolate what the exponent is attached to. So that means I'm going to divide both sides by 16,000. And that will reduce down to 23 over 16. Those 3 zeros will cancel out, canceling out a factor of 10, another factor of 10, and another factor of 10. On the right-hand side, those 1600s cancel out. Excuse me, I said 1600, but that's actually 16,000. And I'm left on the right with 1 plus 822 over 4 to the 4t. And just so this is a little bit simpler, I'm going to get my calculator and let's calculate everything that's in that parenthesis. 1 plus 0.0822 over 4. And as long as it doesn't have too many decimal places, That'll be okay. So we will write out all of those decimal places. So that's 1.02055. We have 23 over 16 equals 1.02055 to the 4t power. So now that we have that exponential isolated, we're going to use our techniques for solving exponentials. We have three basic techniques, which are to relate the bases. That's trying to make the base the same on both sides. We're not able to do that here. The second technique is to take the log of both sides, and the third is to convert to a log. I'm going to use the technique of taking the log of both sides. So I'll continue my work up here. I'm going to do natural log on the left-hand side and natural log on the right-hand side. Introducing the logs allows me to use a property of logs called the power rule. And the power rule will allow you to take that exponent and make it the coefficient of the log. We have natural log of 23 over 16 equals 4t natural log of 1.02055. Now I want to solve for t by dividing both sides by everything else. So I'm going to divide by 4 natural log of 1.02055. Do the same thing on the other side. So now I have an expression for t, that's natural log of 23 over 16 over 4 natural log of 1.02055. Let's bring back the calculator so we can get a decimal approximation for that. That's natural log of 23 over 16 divided by, and I have multiple factors in my denominator, so I want to make sure I put parentheses around that. It's 4 natural log of 1.02055, close parentheses for the log, and close parentheses for the denominator. And so here is my value for time. That's 4.46011. A few more decimal points there. So let's write that down. We have that our time is 4.460118.076. Now, if we look back at the directions here, it says to write our time in years and months. The way it's written right now is years, 4.5 years basically. So in years, we're going to use this 4 here to say 4 years. And this part right here will help me figure out the months. So right now it's in years and I need to convert it to months. So I need to take that portion, 0.460118076, and since there is 12 months in a year, I'm going to multiply this by 12, and that's going to tell me the months. So I'm going to bring back my calculator, and I can subtract 4. That's going to get rid of that 4 years at the front, and then multiply by 12. That's going to convert that portion to months. And if I round that up, that's going to be 6 months. So we have 4 years and 5.5 months, which I am rounding to 6 months. So we found that it takes 4 years and 6 months for Jimmy's $16,000 investment to grow to $23,000 with an interest rate of 8.22% compounded quarterly. Thank you for checking out my videos. Have a great day.